أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. We give thanks to Almighty Allah, the cherisher and the sustainer of the universe, the uncreated creator. Allah, the one who taught men by pen. We ask Allah to bless Prophet Muhammad sallallahu alaihi wasallam. May Allah bless his household, his companions, and the generality of Muslim Ummah to the day of accountability. This is another topic in our chemistry scheme of work for third term, week 5, from the Chm2 Model College, Ibadan, Oyo State, Nigeria, SS2 Chemistry. So this includes lesson 1 and 2 as presented by Mr. Ojekunle Ridwan and Mr. Abdulateef Mansour. The topic here before me is water, solution and solubility. So the part 2, the second part of the topic we started at week 4. So this is week 5. Solution, what does it mean? In chemistry, we have 3 states of matter. We have what we call the solid, we have the liquid, and we have the gas. So here, a solution is a uniform or homogeneous mixture of 2 or more substances. The substances involved may be in form of solid, liquid, or gas. But before you can form what we call a solution, there must be mixture of solute and solvent. That is, as you can see here, solute plus solvent gives us a solution. How do you define a solute? A solute is a dissolved substance, which may be a solid, a liquid, or a gas. While a solvent is a substance, usually a liquid, which dissolves a solid. Although a solvent may be a gas or a solid. For instance, looking at the dissolution of copper 2 tetrahydrosulfate 6, the solid form of it, in this equation, as you can see, CuSO4 will serve as the solute, dissolving inside the water 5H2O as the solvent, giving us CuSO4.5H2O, which is the solution, the aqueous form of it. That is a copper 2 tetrahydrosulfate 6 pentahydrate. Moving forward, water, it is the most common solvent in nature. It is usually regarded or referred to as a universal solvent. Why? Because most substances can get dissolved in it. Water molecule has a structure which is polar in nature. That is, one side of the water molecule is positively charged, while the other side is negatively charged. As you can see in the simple molecular structure of water, having its atom charged, partially charged, as a partial dipole, O as minus, while the 2 hydrogen there as a plus. So meaning that one side of the molecule, which is the oxygen part, is negatively charged, while the hydrogen part is positively charged. In this case, water has the ability to dissolve a lot of solvent. A lot of solute. As a result of this polar structure, water is an excellent solvent for electrovalent solids, such as mineral salts, mineral acids, and bases. These are mainly inorganic substances. All covalent compounds which contain the hydroxyl group will also dissolve easily in water because of this structure it has. Examples of organic solids like sugar and organic liquids like alkanol and propane 1,2,3-triol, also known as glycerol, can also get dissolved in water. Besides, Besides all these we have mentioned, all gases can dissolve in water to some extent. Gases which do not ionize in solution or which react with water, they are found to be very soluble, e.g. in a solvent like ammonia, hydrogen chloride, and nitrogen 4 oxide. Other gases like sulfur 4 oxide, carbon 4 oxide, and chlorine, which ionize only slightly, they are found to be fairly soluble in water. Also, gases which do not ionize at all in water are only sparingly soluble. Examples of such gases are oxygen, they are sparingly soluble, hydrogen is sparingly soluble, nitrogen, same thing goes for carbon 2 oxide. In general, it should be noted that the solubilities of gases decrease with an increase in the temperature, meaning that the higher the temperature, the lower the solubilities of gases. Moving forward, the table here gives us examples of solutions. For instance, we have solution, solute, and solvent. This is a 1, 2, 3 column table with 1, 2, 3, 4, 5, 6 rows. So when you have brine or salt solution, what are the solids present there? NaCl solid plus water. Sugar solution, sugar plus water. Antifreeze, alkanol plus water will give us antifreeze. Soda, CO2 plus water. Brass, that is an alloy. Mixture of zinc and copper. Air, we all know air is a mixture of gases, but it contains mainly oxygen. And nitrogen serves as its solvent, as a diluent. That is why we usually refer nitrogen as the diluent of oxygen. Now, solvent generally, what can they be used for? Uses of solvent. What are the solvents? Serves as a very suitable medium for most chemical reactions, especially in living systems. So when we eat our food, biochemical processes taking place within our body system require water as the medium for which the reactions will take place. Kerosene, petrol, or ammonia solution is used to remove fat, oil, and grease stains. So they are good solvents for removing all these things we don't want on our clothes or clothing materials. Turpentine is used to mix waterproof paints for painting of walls. Besides, we have our oils. When it is dissolved in ethanol, it is used in the manufacture of perfumes. So ethanol there serves as a solvent. The solid iodine in ethanol, forming iodine solution, is used for dressing wounds. Having mentioned the uses of some solvents we'd like to talk about what we call colloids. Under that, we have what we call true solution and colloidal solutions. What are true solutions? Or what is a true solution? A true solution is said to be formed as a result of homogeneous mixture. That is when you have the resultant homogeneous mixture formed. When solute particles dissolve in such a way that they are able to get in between the solvent particles, when solute particles, when they dissolve, and they are able to get in between the solvent particles, that is when you say that a particular solution is a true solution, and it has its own characteristics. When you dissolve sodium chloride in water, copper sulfate in water, all these are going to give us true solutions. So the solute particles in a true solution are too small to be seen by naked eyes, and these solute particles are called crystalloids. On the other hand, we have what we call false solutions or colloidal solutions. The individual solute particles here in these colloidal solutions, they are larger than the particles of true solution. but they are not large enough to be seen by naked eyes. We have here some examples of colloids as starch, albumin, and so on and so forth. Generally, the solute of a true solution, they do not scatter light rays, while a solute of a false solution can scatter light rays. When you have a plain polarized light focused on a true solution inside its container, you will discover that there is scattering of light rays by the particles of the false solution. That is, the solution exhibits the Tyndall effect. Actually, this Tyndall effect was first observed by Michael Faraday. Why the Tyndall effect? As you can see in this diagram here, we have colloid and we have the true solution. This colloid is a false solution, while the solution that is written here is referring to the true solution that we have. So what is the essence, or what causes Tyndall effect? Tyndall effect is due to the size. When you have we know that the colloidal solution or the false solution, they have their size, the size of their solute are smaller than the wavelength of light that is being concentrated on them or that's being passed through them. So therefore, colloidal solutions cannot reflect light. What do? They scatter the light rays that shone on them. Hence, Tyndall effect is witnessed, is seen, is observed. So that is why we say that colloidal solution, they exhibit Tyndall effect by simply scattering the light that is focused on them. As you can see here, so we can observe the light passing through this colloidal solution, but we cannot observe it passing through this true solution. The true solution on the right hand side, the colloidal solution on the left hand side. So the red line pointing at the center of this colloidal solution is actually emphasizing, showing us where we have the Tyndall effect being felt on this diagram. Moving forward, types of colloids. The liquid solvent in the colloidal or false solution is known as dispersion medium, while the solid particles constitute the dispersed substance. The most important colloid is the protoplasm, that is the living part or the living matter that we find in the cells. So protoplasm is the most important colloid that we have, that is the false solution. As in the case of solutions, true solutions, in colloids, that is false solutions, the dispersion medium and the dispersed substance may be a solid, a liquid, or a gas. So as you can see in this table below gives us the classifications based on physical state of dispersed phase and dispersion medium. Dispersed phase here, something like what we can call the solute, while the dispersion medium, it serves as the solvent of the colloidal solution or the false solution. Now, dispersed phase, dispersed medium type of colloid example. If you have a solid dispersed phase in a solid dispersion medium, so the type of colloid there is a solid sol. A solid dispersed phase in a solid dispersion medium. So what you are going to have is solid sol. So example of such solid sols are some colored glasses and gemstones. You can also have solid dispersed phase in a liquid dispersion medium. So that is the common sol we have around us. So examples of that kind of sol is found in paints, self-rules, and the likes. We can also have a solid dispersed phase in a gaseous medium, that is aerosol, as we have in our smoke and dust. If you have a solid dispersed phase in a gaseous or in a gas medium, so that is when you have what we call the aerosol. So solid being settled in the air. As we have the coronavirus as a solid substance settled in the air. So in that kind of situation, you can say you have had what we call the aerosol. So as you have smoke settled in the air, so the particles of smoke, they are in form of solid and they are settled in the gaseous environment. So you can have smoke, dust as the examples of these aerosol. So the same thing applies to others, as we can see on this table. Now, it should be noted that dispersed particles in colloids cannot be separated from the medium by filtration, but can be precipitated or coagulated by the addition of solutions containing metal ions. Yes, that is why if you are preparing a starch, like you want to prepare your starch in form of amala or things like that, addition of compounds like sodium chloride will make the starch to become precipitated such a way that the colloid, the sol, will not be properly formed again. It will definitely interfere with the proper formation of the thick sol. And sol can also have a thicker form that we call the gel. Yes, sols and gel. So when you have your sol becoming more thicker, you understand? So most salts that can solidify under certain conditions to form what we call gels. Yes. Moving forward, we also have what we call suspensions. These suspensions, they are just like a false solution, but they are not really false solution. But what is different? A suspension is a heterogeneous mixture of undissolved particles in a given medium. The particles are usually large enough to be seen without the aid of an instrument. You don't need any instrument to feel the particles present in what we call a suspension. And they eventually settle down if left standing. For instance, the harmattan is an example of a suspension of dust and fine sand particles in the air. So if you have your harmattan, you have observed that before, maybe on your windows, on your doors, on your tables, on your clothes, on your television, everywhere. It's possible for harmattan to become settled on them. So this kind of thing is called a suspension. You can have solid suspension. Most commonly, you can have liquid suspensions. So inshallah, we would like to stop here for today. So far, so good. As far as this lesson 1 of week 5 is concerned, we have been able to talk about solutions, the types of solution, the definition of solution. We have been able to emphasize water as a universal solvent. We have been able to look at types of solutions that we have. So the different examples of solutions. We have been able to look at the uses of a solvent and colloids, the first solution, how they exhibit what we call the Tyndall effect. Besides, so we have also been able to look at the types of colloids. We have been able to look at what we call a suspension. Before I go, we should know that there are some differences between true solution and false solution. Number 1, true solution, the solute of true solution can pass through a filter paper, while the solute of false solution can also pass through a filter paper. If you are trying to compare here, so if you have a filter paper, the solute of true solution can pass through. Also, false solution can also pass through. The solution can be dialyzed for true solution. That is, the solute can diffuse when you have a semi-permeable membrane. The solution of false solution, the solute of false solution cannot be dialyzed, cannot be made to undergo dialysis. Then the solutes do not scatter light rays as for true solution. The solute can scatter light rays for false solution, that is, they exhibit what we call the Tyndall effect. So I pray Allah subhanahu wa ta'ala grant us the knowledge, wisdom, and understanding. So may Allah bless our knowledge. Till we meet for the next lesson, which is lesson 2, I say Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.